Advent of Code 2022. Let's solve day 24 Blizzard Basin. Hey everyone. In this problem, we are given a grid, which basically represents a valley, and the hash symbols are the walls of this valley. And you can see there are two gaps in these walls. One is over here, from where you can enter the valley, and then we have another one here, where we exit from. All the periods basically mean empty spaces, and then we have these other characters, which basically represents a blizzard and the movement of it. So we'll have four kinds of blizzards. One will point up, then down, then left, and then right. And then there are a bunch of rules. Let's go through them. So it says that in the map above, they have two blizzards, one moving right and the other one moving down, which we can see right here. It's going towards right and this one is going down. And then it says in 1 minute, it moves one position in the direction it's pointing at. So in this case, this blizzard moved from here to the next position right here. And this one moved from this position right here. But now what happens when it hits a wall? That's where this conservation of blizzard energy comes into play. So scrolling down, it looks like if it hits the wall and then on the next minute, it basically respawns on the top of the column, which will be right here. And then of course, this blizzard keeps moving. But now what happens if two blizzards collide? As we can see, it's going to happen to these two blizzards right here. In that case, looks like they're made of tiny snowflakes and they just pass right through each other. And here it gets represented as number 2. And then as the blizzard moves, they just resolve and they become independent blizzards again. And then this right blizzard does the same thing. It hits a wall and then it respawns on the leftmost side, which we can see right here. Okay, then we have a very complex example here, which I don't think I want to go through, but it says our expedition begins in the only non-wall position in the top row, and we need to reach the only non-wall portion in the bottom row. That is, enter from here and exit right here. And it says on every minute, we can either move up, down, left, right, or we can wait in place. And that we and the blizzards, we move simultaneously. And at all costs, we have to avoid the blizzard. Okay, and then it looks like they have an example where they use the previous grid that we saw. And we start at this position E, and then it runs through all the steps that it takes to reach towards the end. I'm going to skip this part. You can go through this by yourself. But it's basically moving to the next empty spot and trying to avoid all the blizzards. And by move 18, it reaches the end right here. Then the question is, what's the fewest number of minutes required to avoid the blizzards and reach the goal? So this sounds like a very classic breadth-first search in a matrix. We just have so many other constraints to determine where we can go next. I'm going to solve this one in JavaScript because that's just a language I picked. I could have chosen Python, Java, or so many other languages, but I just stuck to JavaScript. Okay, so let's solve this. The first thing we need to do is get the puzzle input. So we're just right here. I open this in a new tab. Let me copy this and head over to my IDE. I already have the JS file created and I'm using Visual Studio Code for this. I have a hello world here. Let's make sure this works. So we'll run it by node and then solution.js. And we can see hello world being printed here. Okay, let's create another file here. Let's call it input. And let's put our input that we just copied right here. Okay, next let's try to get rid of this, and I'll create a function called solve, and in here let's try to read the input file that we have, and we can probably use fs for this. Okay, this does fs, and then in here let's get our input in grid input, and let's do fs dot read file sync. And then let's get the current directory's name, which will be dir name, and then input. Okay, so this will give us everything as a buffer. So let's convert it to a string, and then we'll split it on the new lines. Okay, well, let's see how this looks like. We can console log the grid input, and let's run this. Oops, I haven't called this method, so we need to call that. Let's try to run this again. And yeah, we can see we have some junk right here. Let's try to make this more beautiful. So next, let's create a blizzard map. We can call it as blizzard map because that's what this input is. And we can say grid input dot map. So now we have each row or each individual strings, and we can probably split it on nothing. So basically splitting every single character. And then let's create a map out of it where we have the item. And so here, what I want to do is for each of the array elements, I want to store one or more blizzards because multiple blizzards can be at the same position. So I want to make sure I'm able to track them. And also we'll be tracking all the walls because blizzards can't go through them, and it will just be handy to have that information with us. So we can basically do item. If item is, let's say, a period, which is the open space, then there is nothing there. Otherwise, we store the current character in an array. Now this could either be a wall or a blizzard. Then we know our start position was the 0th row, but the first column. And I'll open the input as well just to show that it's right here. So this is the 0th row and the first column. So jumping back, and then our destination will be, let's say destination position. It will be the blizzard map dot length -1, which is basically the last row. And then blizzard map, let's take the first row, find its length, and -1 to get the last column, but I think we have to go to the second last column, so we'll do another -1. And let's just double check that. Going back to the input, going to the last element, we can say it's not the last column but second to last column. Okay, so now we have everything that we want. We have the start position, we know where we have to go, and we have the blizzard map. So let's create another method. Let's call it getMinutes, and this can take the blizzard map, the start position, and the destination position. Let's initialize a variable called steps, or you can even call it minutes, but I'm just using steps. Then we run an infinite loop while 1, and because we're in the loop already, let's increase our steps by 1. So the first thing we need to do is move our blizzard positions. So let's create another method. We'll call it move blizzards, and we'll pass it our blizzards map. And from this, I'd expect to get the new array with the updated positions of all the blizzards. So let's see how we'll write that. So creating the function move blizzards, and this will take the blizzard map as the input. So let's create a new blizzard map. We can call it new blizzard map, and we can initialize it like this. We'll map over each row of the current blizzard map, and we'll basically create a new array of the length of the current row, and let's fill it with an empty array. Okay, so this should give us a new blizzard map which is completely empty. Next, let's start our iteration. So for row equal to 0, row smaller than our blizzard map's total length, and row ++, just boring loops, copying this and doing the same thing for column. And as for the range, we can just use the first row. Okay, so let's see everything we have at this position. So let's say blizzards at current position, which will be blizzard map, then the row and the column. Now this should be an array which either represents a bunch of blizzards or it's just a wall. So let's go through each of these. For blizzard, possibly blizzard or a wall of blizzards at current position. Let's check if this blizzard is actually a wall, which is represented by the hash symbol. If it is, then in our new blizzard map, we can simply do row column as the wall, because that's what we did when we initialized it as well by doing this. Otherwise, if it's a blizzard, then we need to find the next position of this blizzard. So let's say we'll create a new method which says get next blizzard position, and to that we can pass the map of the blizzard, its current position, and the symbol of a blizzard. And then in our map, we'll basically use this next position. We'll assume that the first element represents the row, so this becomes next position 0, then this becomes next position 1, and in here we just concatenate whatever already exists. So we'll just do expansion of the array and then put our new blizzard in there. Let me reduce the sizes here so it's more readable. I can even break it in the new line. Okay, so basically we just added blizzard to whatever existed over here. And at the end of this function, we'll just return this new blizzards map. Whoops, not here, right here. Okay, so now let's create this other method, which is get blizzard's position. So creating a new function, and this will take the blizzard map and the blizzard. I would like to rename some of these. We can call this as start row, and this can be called as end column. And this basically represents the direction where the blizzard is moving. And that reminds me, we should create another constant. Let's say blizzard movement, and it can be an object. Its keys can be the different directions we know of. So the first one is top, then we'll have 3 more elements, one representing right, bottom, and then left. Now this shows the diff. So if you're moving upwards, we'll reduce our row by 1 and we'll keep our column the same. If you're going towards right, we keep our row as the same and we increase our column by 1. And if you're going down, we increase our row by 1, keep column same. And if you're going towards left, we keep our row as the same, but reduce column by 1. Okay, so in here, let's use this blizzard movement that we just created. Oops, there's a typo, blizzard. In here, and let's do const. Let's find our next movement, which will be this blizzard movement, and then the direction we are headed. So let's initialize 2 more variables. So the new row, which will be initialized to start row itself, and then we have new column, which will be initialized to end column. Okay, so basically this new row should be new row plus movement and the 0th element, and the same goes for the column, and this will be the first index here. But the problem is this new row or this new column could either be out of bounds of the grid or it could be on a wall. So let's run a loop here. So I think this will require a do while loop, and we'll keep moving in the direction as long as the new row and new column values are not valid. And in our case, we first need to look at the blizzard map, and if the new row and the new column that is at this position, if we have a wall, then this is just not right. And let me move this in there. So after we do this, we need to do another thing. We basically need to wrap around if we are out of bounds. So let's create another function. I love creating functions because they really make things independent and it makes it really easy to debug. So here, let's create another function called isPosition out of bounds. And this will take in the row, the column, and the grid. And this will basically return if row is smaller than 0, then yes, you're out of bound. If row is greater than the grid length -1, which is basically the maximum number of rows, then yes, you're out of bound. And the same goes for the column. So if the column is less than 0, then you're out of bound. And if the column is greater than, let's say, grid 0 length, which is the maximum column -1, then you're out of bound of the grid. So if you're out of bounds, what should we do? We should basically wrap around, right? So let's create another function which basically wraps around the grid if needed. In here, it will take the same input as row, grid, and the column. And here we'll check if we are out of bounds. So what do we do in that case? Rather, let's do it the other way. If you're not out of bounds, then let's just return what was the input to us, which is row and column, because there's nothing to change here and this is a valid set of coordinates. Otherwise, let's initialize 2 more variables. Let new row equal to the current row that was passed to us. Let's do the same for column, new column. And now we have multiple conditions that we'll have to write. If row is less than 0, so this basically moves that the blizzard is moving upwards. So in that case, the new row will be the bottommost row, because when you wrap from the top, you have to end up in the bottom. So that just becomes grid length -1. If the row is greater than grid length -1, that is, we are beyond the maximum row that we have. That means the blizzard is moving downwards. Then we just go back on the top. And same applies for the column. At least it's a similar idea. So if the column is smaller than 0, that means we are moving towards the left. So our new column will become grid 0 length, which just gives you the maximum amount of columns. And we just do -1 to fix the indexing. So we just wrap it towards the last column. Otherwise, if column is greater than the maximum amount of columns that we have, then we just update our new column to be 0. That is, you just wrap around to the first column. And I just realized I messed up here. This should be new row. And once we're done with this, we just do the same, return row column, but in this case, it's the new column and the new row that we have. Phew, okay, that was a lot. So let's copy this method name and use it in our getting the next blizzard position. So we have a new column and new row. Let's see if we need to wrap around it. So in here, we pass the new row and the new column and then our blizzard map. Okay, and then we get a new position, which can then be assigned to new row. So new row becomes new position 1, and this becomes new column, and this becomes 0 and 1. And I think we can clean this up a little. Let's move this over here. Let's move this one over here, and we can clean this assignment, which was unnecessary. Okay, removing this comment. I think this makes sense. Now, similar to the previous position methods that we wrote, here we need to return the new row that we have and the new column that we have after all the wraparound and figuring out what the position should be after hitting all the walls. Okay, so let's see what's next. Anything else we need to do on our move blizzards? Looks fine. We go to the row, we go to the column, we get the blizzards at the current position. Then we check if it's a wall. If it is, then we just put the wall in our new blizzards map. Otherwise, we get the new blizzard position and then append it to the new blizzards map at the same position. We just add a blizzard in there. Okay, so let's go back to our getMinutes method and see what do we have here. So we have our new position for the blizzard. Now the next thing that we need is where the humans are. So we know we have a start position, but from the start position we can go in multiple directions. Like going back to the example, taking this grid right here. If we are at this position, we can basically go on top over here or on bottom over here. So this breadth first search becomes a greedy search in a way. We try to explore every possible options where the human can go. So we need to maintain some kind of a list which shows all the positions which has been possible for the human at the current step. And then we keep doing breadth first search using those positions. So going back to our ID, let's create another array here. Let's call it current positions. So this will be an array. And in here, let's start by our start position, which is basically where we start from. Now in our while loop, we have the new position of the blizzard. Now let's see on this new blizzard map what all places we can move. For that, let's start iterating over our current positions. So we can do current position of all the current positions that we have, and we'll create yet another method where we get all of our next positions from. So let's call it get next positions for human, and we can pass the blizzard map to it and where we are right now. So let's create this method get next positions for human. Creating a new function, let's call it next positions for human. It takes in the blizzard map and our current position. So because we can go in multiple directions here, let's create an array next positions. It'll be an empty array right now, and this is what we'll return from this method. And before we write this, we also need to create another array which defines all the possible movements of a human. So going back up right here where we have the blizzard movement defined, we can define another array here which says human movements. So this should contain 5 movements, 4 of which are exactly this. So we can simply do object.values and then the blizzard movements, and then the other movement is 0, 0. That is, don't move at all and stay at your current position. Okay, so going back to our method that we were working on, here let's iterate on all the movements that we defined above for human. So for like movement of human movements, we get a new row position, which will be current position, the 0th element plus the movement, and we take the 0th index from it as well. And we do the same for column. So the new column position becomes the current position at first index and movement at first index. Now, just like the blizzards, these new positions can be out of bound as well. So let's add a check for that. So if, I think we created a method for that called is position out of bounds, which takes in the new position, which is our new row, and then the new column, and then we pass it the blizzard map. So if the next position is out of bounds, then we just skip this movement and we can continue with our loop to go to the next movement. Otherwise, we should check if the blizzard map has a blizzard at this position, and we can do that by using the new position, which is the new row and the new column. And if its length is greater than 0, that is, if there's a blizzard here or if there's a wall here, then this is again not the right position for us or not the right move for us. So we can continue and skip this movement. Otherwise, we add this new set of position to our next positions. So next positions dot push, and we add the new row position and the new column position. Okay, so going back to get minutes now. So now we have our next possible positions. And one thing that we need to realize is from all of these positions that we are iterating on, we will be getting multiple positions for each of those current positions. And many of those positions might be the same. For example, going back to the grid that we used before, let's say if one of your positions is this E and the other position was here, then both of these positions will want to go to this position here, which will then be a duplicate. So we need some mechanism to figure out that for a given step, are we tracking multiple instances of the same position. So to detect that, let's create a new array where we can track all of these duplicates. Let's create it right here. Let's call it dDuPositions, and we'll initialize it using the method we've done before. So we'll do blizzard map dot map, then we get the row, and then we do a new array, and we take the row length and then fill it with false. That is, this position hasn't been marked right now to be used. So once we get our next positions, let's go over them. So let's do for let next position of next positions, and let's mark true at all of these spots. So dDuPositions, let's access the column, which will be done by next position at 0th index, and then we have next position at the first index, and then we mark it as true. Okay, so after this for loop runs, for all of the current positions that we know, and for all of the possible next positions, our dDuPosition array should have all the positions which are the next candidate for our human. So let's iterate on this now. Let's run a for loop again. Let row equal to 0. Row is smaller than the blizzard map dot length, and then row plus plus. Let's do the same for column call, and we can technically use dDuPositions as well. I just used blizzard map because it doesn't really matter much. Then 0 dot length, and we'll increment our column. Oh, and this should be column as well. Okay, so now let's grab our new position, which will be row and column. Let's see if this position was marked as a valid position. So we do dDuPositions, row, and then column. If it's true, that means this is the next position for the human. Oh, and looks like there's an error here that I just noticed. It has a missing closing square bracket. Okay, that looks good. So if this is a valid position for our human, we need to add it to a list of positions, which will be used in the next iteration. So let's create another array here. Let's call it new positions, and it'll be an empty array. And let's just push this position in there. So this will basically become this new position, and then our current position should be reassigned as the while loop ends. It should be right here, and new positions become our current positions when we go on the next iteration. We need to add one more condition here before we add the new position as our new positions. There could be a possibility that this is the destination that we were looking for. So let's add an if statement here. If row is the destination positions 0th index, and column is destination positions first index, then this is where we had to come. And we can basically just return the number of steps you've executed so far and end the program. Otherwise, we just continue what we had here, where we add the new position to a list of positions and then continue with our loop. So now let's call this get minutes down here in our solve. So get minutes, and this takes in the blizzard map start and destination position. So the blizzard map start position and the destination position. Let's get the minutes here, and we can console log to see if it really works. And before we run it on our given input, let's try to use the test case that's provided to us, which is this first grid right here. Okay, so I'll copy this and go back to our input, and I'll paste it. And then let me fix this E here, which should basically be a period. Let's run this, and the output seems to be 19, whereas it should be 18, I guess. Yeah, scrolling down, we can see the answer is 18. Okay, so let's see what could be the problem in our program. So looking up, let's see what we do in our get minutes. We have this current positions, and okay, the steps needs to be 0 because we incremented immediately, and that would explain why we got off by one problem. And that's the hardest problem in computer science to solve. So let's run this program again, and we can see we have 18 right here. And I noticed there was another issue, which wasn't really an issue, but was a bad variable naming. Just end column right here. This should basically be start column and not end. Okay, so now let's run this for our actual input, which is this one. So running this program, you can see the answer is 299. Let's try to submit this on Advent of Code, and fingers crossed. And this was the right answer. And we got 1 gold star, and now we are closer to collecting enough star fruit. Let's continue to part 2. Looks like some elves forgot their snacks at the entrance of the valley. So now we are being requested to go back to get the snacks. So we start with the same initial conditions, and we have to figure out how quickly can we make it from start to the goal, then back to the start, and then again back to the goal. So basically going from here to here and then going back here and then coming back. So let's see how we can solve this. Going back to our solution, which is down here. So right now from get minutes, we get the minutes elapsed for this first run from start to end. And because we pass start and destination, we can just swap them and get the rest of the minutes. But this blizzard map changes as well. So we need to update this get minutes method to return the blizzard map to us as well. So going back to get minutes and seeing where we return the results, we return the steps here. Here we can return an object, which can be steps and the blizzard map itself. So going back to where we use it, we can call it result. Let's call it result1. And then our new blizzard map becomes result1.blizzardmap. And because it's a const, let's make this a variable. So we need to run this 2 more times. In the second round, our destination becomes our start and our start becomes our destination. And then this becomes result2.blizzardmap. And then we get the third result. And I don't think we need the blizzard map here anymore. And then we just sum up all of our minutes. So that'll be result1.minutes, then result2.minutes, and then result3.minutes. Okay, let's run it on the example that was given to us, which was this one. And let's see how this performs. Oh, we get not a number. Let's see, what did we do wrong? Oh, we're returning steps here from our method. So these needs to be steps. Let's run the program again. And we can see we get 54 as the answer. Let's go back to advent of code and see if this matches, which is 54. Now let's run it against the actual input, which is right here. And running this program, we get 899 as the answer. Let's try to give it to the advent of code and see if this works. And this was the right answer. And we got another gold star. I hope you had fun solving this problem. I'm really enjoying this advent of code. I usually don't like competitive programming, but the nice narrative and story that this has, it really makes it more enjoyable. I've solved a lot of these questions and I'll be creating more videos. And right now, this is my first video on this topic. That's why we have solved 24, which is the second hardest question, I'm assuming, given tomorrow we unlock the finale. Anyhow, if you like this video, please don't forget to like and subscribe to my channel. And I've launched my Patreon recently. Please do check it out. You'll be one of the early adopters if you sign up to my Patreon, and it will grant you direct access to me, where we can discuss these problems or any career advice or just anything that you need. Please remember, this is only for your early adopters, and I think that's the best Patreon offering that I can offer. Well, thank you so much for watching this video. If you made it so far, keep solving these challenges and keep an eye out for more of my videos. Happy holidays.